The Wye Delta Transformation has specific applications, but is also useful when we can't reduce combinations of resistors into just a simple equivalent resistor. So let me show you a motivation, and I'll walk you through the derivation of the Wye Delta Transformation. So let's assume that you were faced with this circuit, and let's focus on one of them. Let's focus on this particular circuit, and we were asked, for example, what's the R equivalent or the equivalent resistance seen by this particular source. You might be saying, well, you know what, I think R1 and R2, well, they're not in series. R2 and R3, they're not in parallel. And you can spend some time on it, and you'll realize none of these resistors are in series and none of them are in parallel, and it's sort of impossible in this particular formation to just reduce them into one resistance. And what I have done in here is I've redrawn that circuit. They're exactly the same circuit, these and these two. I just, instead of having this particular formation, I just basically made it that way and this way. You might be able to see it better this way. Yes, R1 and R2, they might seem to be in parallel, but they're not. They do share this node, but they do not share a node down here because there's an R3. Similarly for R4 and R3, and you can see R3 is neither in parallel or in series in any of them. So how do we go about solving this particular technique? Well, as it turns out, that there's a specific transformation that we call delta Y transformation or Wye Delta Transformation. So this is the delta. It looks like a triangle, or this is another delta in here, or we can see it as a Y in here. And but with training, you'll be able to start seeing these particular transformation. But typically, you'll see it this way. You'll see that we have a delta, and we have, well, this is not a Y. Well, it's a flipped Y. I mean, this is a Y, but it's just upside down Y. And this is called the Wye Delta Transformation. Sometimes you will see instead of a Y, these arranged are in T. We call it a T. And this one here will be arranged in like another resistor here, and it's called a pi because it's a flipped pi. Okay, so, but anyway, I'll refer to it as a Wye Delta, and we'll go from there. So the way we derive it is the following. So what we can do is we can put both of these transformation, or both of them into boxes, okay? What I mean by that is usually you have black boxes that appear around circuits, okay, like this, and we have another box right here, okay, and here's another box, okay, and the idea behind it is the following. What we need is this here is A, this one here is C, this one here is B, this is A, B, C. It's already labeled for me. The idea behind this is like, if I don't know what's inside this box and what I know inside these boxes, and I need them to be equivalent, I need to measure the resistance between A and C, and it will be the same resistance between A and C in here. If I measure the resistance between A and B in here, it will be the same resistance as C between A and B. If I measure the resistance between C and B in here, it will be between C and B in here, the same. So if I take any two and I just measure the resistance between them, it will appear to be the same. And I'll use this technique to figure out how we can transform from one formation to another. So I'll start by saying, okay, let's do the following. Let's open up B, okay, and I'll just write it in here. Let's open port B, okay, I'm gonna call it just B. By opening, meaning you see this wire in here, we're gonna just not connect it to anything in here, and we're not gonna connect anything in here. And let's see what's basically the resistance seen by A and C in here. What's the resistance seen by A and C in here? Okay, so I'll do that in here. I'll do this, and I'll just zoom out a little bit. So of course, if we open up B in here, that means that makes R2 and R3 in series, since nothing is connected in here. Yes, there's a wire, but this wire is connected nowhere, so it doesn't exist. So R2 and R3 becomes in series, and that resulting R2 and R3 in series becomes in parallel with an R1, and we'll be able to see what RAC is. That's how we can do that. So let me just do this here. So we can say the RAC for the delta formation is simply R2 in parallel with R3, in series with R3. So we add them, and it is going to be, the combination will be in parallel with R1. And we can say that this is simply R1 times R2 plus R1 times R3 divided by R1 plus R2 plus R3. And if you didn't follow, what I've done is the following. I'll just write it here very quickly. I basically said, well, I know that it's R1, like they're in parallel, so I have to multiply R1 times R2 plus R3. And then what I did is I distributed R1 to R2 and R3, and that's basically what you see in here. And of course, we divided by R1 plus R2 plus R3, and that's basically what you see down in here as well. Okay, so I just did a few computation in my head. Anyway, so this is what we see from the delta formation. Let's see what happens if we open up B from the Y perspective. So if we open up this one here and we didn't connect it to anything, so this particular resistor will be basically not connected. And what we have is this is simply RA plus RC, they're in series. So we can say the RAC is simply RA plus RC. We can do the same thing by opening a different port. For example, we can open up now port C, and let me highlight it here. Okay, we can open up port C and let's see what would happen. So we can say open terminal or port C, okay? And at that particular moment, it becomes, since this is open, that means R1 and R3 are in series and they will be in parallel with R2. So let me just write that. So it becomes RAB is simply R1 plus R3, they're in series and both are in parallel with the R2. And we can simply say that this is R1 R2 plus R2 R3 divided by R1 plus R2 plus R3, and that's RAB. And we can do something similar in here. If we open up that C, that means this doesn't exist, so that becomes RA and RB in series, okay? So in here it becomes RAB is simply RA plus RB. Yep. All right, so we'll move on, and what do we have now? Well, the last port in here. So we open up A, we opened up B, C, and then now what we do is we can go to A, and A in here, we open it up. By opening this up, basically I'm saying, okay, this is open, that means the 2 and 3 are in series, and they're in parallel with the R3. Okay, so 1 plus 2 in parallel with the 3. 1 plus 2 are 1 plus R2, and they're in parallel with R3, and that's simply R, I believe that will be BC, okay? That will be BC, and we can just basically say this is R1 times R3 plus R2 times R3 divided by R1 plus R2 plus R3. And if we take a look at the Y formation, if we open up this one here, this doesn't exist. That means the B and the C are in series, okay? So that means RBC becomes RB plus RC. Now let me highlight what's important in here and let's clean up some of them. So this is here is important, this one here is important with that. Okay, and of course we do that with this and then those, and then of course this one here with those guys in here and this one. So what this tells me is, of course, the RAC and the RAC are the same, so these here are equivalent. So let me just write that down. And of course we can say that this one here is also equivalent to these, and we can say that this one here is equivalent to these. So let me just write these down for you. So all I have to do is, after I clean them, to clean up some of these equations. So if we call this 1, we call this 2, and we call this 3, and let's assume that what we're interested in is maybe interested in figuring out what RA is. So what we can do is we can say, all right, let's do 1 plus 2 minus 3. That will give me, if I take a look at this side first, because it's simpler, that will give me RA plus RC plus RA plus RB minus RB minus RC equals, and of course if you clean it up a little bit you will see that it's simply 2RA in here. That's what I'm having, because RB will go with RB, RC will go with RC, and I have 2 RAs. Okay, on the other side in here what I have is the following. I'll have R1 R2 plus R1 R3 plus R1 R2 plus R2 R3 minus R1 R3 minus R2 R3 divided by R1 plus R2 plus R3. So all I did is I basically summed this numerator and subtracted this one from here, and that's what you see. So we can clean it up as well in here. So let me just do that. So by cleaning up, meaning, okay, let me just do this here. I believe I have R1 and R3 and R1 and R3, so let me just do that. So here, well, why don't I just highlight them and then delete them? So R1 and R3, R1 and R3, and then we have R2 and 3 and R2 and 3. Okay, so we delete those in here, and we delete that in here. So that leaves me with R1, R2 twice, so that basically make it 2 R1, R2. Okay, and of course this 2 will go with this 2 in here, and that basically is one of the transformation that we can do. What we did is in here you will see that we were able to figure out with the value of RA which is in the Y formation using R1, R2, R3. Let me just highlight this equation again. You see this is RA using the formation R1, R2, R3 in here. We can do the same type of analysis for all of them, for all of the R's. So for example, I can figure out what RB is, and I can figure out what RC is. And the transformation is pretty straightforward and simple. So let me show you. There's a pattern to it. So the pattern is the following. So I've copied and pasted the picture here so we can see it. So what we're interested in is R of A, and what we needed to do is we needed to multiply R1 and R2 and then divided by the sum. So if we're interested in RB here, it's pretty much the same. What we need to do is multiply R2 times R3 divided by the sum. So let me just write this for you. So that becomes basically R2 times R3 divided by R1 plus R2 plus R3. You can get to this answer not only by pattern recognition, but by basically having these 1, 2, 3 solved slightly differently. So if we were interested in B, that means I would have isolated these. Maybe I will sum 2 and 3 and subtract a 1, and I'll get to that answer as well. Okay, so what if we're interested into R of C? Well, R of C is here, so I'm going to multiply R1 times R3 this time. So that basically tells me you multiply R1 times R3 divided by R1 plus R2 plus R3. And at this particular moment, if we were given a delta transformation, we will be able to go to a Y transformation in here. That's just one way, okay, because we were able to compute RA, RB, and RC. And we can do similar type of analysis, but this time what we will be doing is we'll be going from the Y to the delta transformation. In this particular case, I'm interested, instead of RA, RB, RC, I'll be interested in R1, R2, R3 in terms of RABC. You can, again, go back to these equations and figure out a way to isolate the R1s and the R2s, but I'll give you the pattern right away right now. It's just because it's simple. There's a pattern to it too. It might be also simpler and easier to see that pattern if we draw it this way, and it'll become a little bit easier when we're actually doing to get basically Y to delta. Okay, so let me just draw this here. So what we can do is we can say this here, and this one here, and this one here. That's basically the delta. That's what we're trying to get to, but we can get to it from the Y, and this is basically the Y, and then this one here, and then this one here. And just to have the same names, what we have is we have R1, we have R2, and we have R3, and this is simply here is RA, and this one here is RC, and this one here is RB. So what we can do is we can convert it from the Y to the delta, basically from the red to the blue in here, by saying, well, we're looking for R1. Well, it's simple to say, well, what you need to do is you need RA times RB plus RB times RC plus RC times RA divided by, well, what are we looking for? We're looking for R1, so we take a look at the RB, which is right in front of it. So we divide by R of B. Okay, this is how we convert from Y to delta. So let me repeat. Well, for R2, what do we do? Well, it's simple. RA times RB here. So if for the 2, what we do is like A times B, and then B times C, and then C times A. So we can write all of these. B times C times RC plus RC times RA. And this time what we're looking for is R of 2. So that means we're going to have to take a look at the RC right in front of it. So this is the RC here. Okay, and the last one, which is R3, we can do, it's the same numerator, RA, RB plus RB, RC plus RC, RA. And this time we can say, well, we're looking for the 3, which is right here. So we'll take a look at the RA in here. So that's basically divided by RA. So this is how we convert from Y to delta and delta to Y. And just to make sure that it's clear, I'm not basically drawing them in the same circuit. I just basically overimpose them in each other just so that it's easier to see the pattern. But typically what we do is we're converting from the red to the blue or the blue to the red, depending on what the circuit we have, and maybe it'll make our life easier. Now, a few things to know: if these resistors are equivalent, this is something nice to know. So if we have, like, for example, happen to be the R1 equals, let's assume that we're moving from delta, from the Y to delta, the one that we just did. And what happens is we were told that RA equals RB equals RC. So what you can see is you can substitute, and let's assume that it's equal R, and you can substitute all of these. You're going to see that this is R squared divided by R. So it's simply R1 becomes, again, R squared plus 3R squares divided by R, or simply 3R, okay? and this basically appears to all of them. This appears for R1, R2, or R3. So this is, we can say the R delta becomes Y of RY. If we said that these are the R of Y, the ABC is the Y. Okay, so this is if they're all equivalent. Now, if similarly, what we said is we said R1 equals R2 equals R3, and it just happened to be R delta. We can say, well, R of Y is simply 1/3 of R delta. Okay, you can do the same type of analysis in here. You can substitute it in here, and you can figure out, like, let's assume that this is, instead of R1, 2, 3, what we have is R delta. R delta, this is R delta squared divided by 3 R delta. Okay, the R delta goes in here, so it's R delta divided by 3, and this is R of Y, and they're all equivalent.